For more than 100 years, we've explored the universe by looking at it. But what if we could listen to it? Well, a brand new signal coming from the absolute depths of space is letting us do just that. And as we listen, it's proving some of the most mind-bending theories from the greatest minds in physics.
And it all starts right here, with a signal so powerful, so incredibly clear, that the scientist who found it said it was like a whisper suddenly becoming a shout. This thing, officially called GW250114, isn't just another blip on a radar. It's giving us one of our best ever looks into the most extreme objects in the entire cosmos.
So where did this cosmic shout come from? From an event of almost unimaginable violence. Imagine two enormous black holes, each one more than 30 times the mass of our Sun, spiraling into each other at incredible speeds and finally smashing together to become one.
Now, to really get why this is such a huge deal, we've got to cover a couple of key ideas, How is it even possible to hear something that happened billions of light years away?
Okay, it all circles back to Albert Einstein. Way back in 1915, he predicted that huge, cataclysmic events, like say two black holes colliding, would actually create ripples in the fabric of space-time itself. The best way to think about it is like dropping a bowling ball onto a trampoline. Those vibrations that spread out, those are gravitational waves.
And at the center of this story, of course, are black holes. They're defined by this thing called the event horizon. That's the ultimate point of no return. And here's the crucial part to remember. The more massive a black hole is, the bigger its event horizon is. Just keep that little fact in your back pocket. This discovery didn't just happen overnight. It's really the climax of over a century of incredible work. It starts with Einstein's wild prediction, then Stephen Hawking comes along with an amazing theorem in '71, fast forward to 2015 when we finally detect the first wave, and now, here we are with this incredible cosmic shout. Every single step made the next one possible.
So all that history, all that buildup, leads us to the first massive breakthrough from this new signal. A truly stunning confirmation of a theory from the one and only Stephen Hawking. So Hawking came up with this idea that sounds pretty simple, but it's incredibly profound. He basically said that when two black holes merge, the surface area of the new combined event horizon has to be bigger than the two originals added together. It's like a fundamental law of the universe. The area can only go up, never down.
But it was just a theory. Until now, for the very first time, we got a signal that was clean enough to actually test it with insane precision. The data showed that two original black holes had a combined area of about 240,000 square kilometers. The new one? A massive 400,000. The numbers lined up perfectly. The theory held. Hawking was right.
To try and wrap your head around that increase, it's kind of like taking the entire landmass of the United Kingdom and squishing it together to create something brand new that's the size of Sweden. It's a huge jump in size, exactly like Hawking said it would be.
But hold on, that's not all this cosmic shout told us. It also let scientists listen in on the unique voice of this brand new black hole as it sort of settled into existence.
See, right after a merger that violent, the new bigger black hole is all disturbed and unstable. It actually wobbles and vibrates, kind of like a bell right after you strike it with a hammer. And as it settles, it radiates all that extra energy away as gravitational waves. They call this process the ring down.
So let's break it down. First, you get the violent merger. That creates this wobbly, vibrating new black hole. Then, as it calms down, it sends out these really specific gravitational tones across the universe. And by listening to those tones, scientists can figure out literally everything there is to know about it.
And this is where things get almost beautifully simple. I mean, think about a star. To describe it, you need a whole laundry list of things. Its temperature, what it's made of, its age, how bright it is. But a black hole? According to a theory by mathematician Roy Kerr, you only need two numbers, its mass and how fast it's spinning. That's it. It's just elegant.
Now, up until this point, all the other gravitational wave signals were just too faint, too muddled, to really test this two numbers idea. But GW250114 was different. It was so loud, so clean, that for the first time ever, scientists could actually pick out two separate, distinct tones from the ring down. And those tones perfectly matched what you'd expect from a black hole that's only defined by its mass and spin. It was an incredible confirmation of Kerr's theory. So this one single event confirmed major theories from Einstein, Hawking, and Kerr. This is way more than just a discovery. It's signaling the dawn of a completely new era in astronomy, and it's all made possible by some of the most sensitive machines humans have ever built.
So, how sensitive are we talking about? The detectors that heard this signal, they can measure a distortion in space-time that is 1/10,000th the width of a single proton. I mean, just let that sink in for a second. It's a level of precision that basically breaks your brain. It's almost impossible to even imagine.
In fact, the challenge was so insane that even one of the project's co-founders, the Nobel Prize winner Kip Thorne, admitted he thought it had almost no chance of actually working. The technical problems were just enormous. They literally had to invent whole new fields of technology just to pull it off.
And here's the best part. Albert Einstein, the very person who dreamed up these waves in the first place, was convinced that we would never, ever be able to build an instrument sensitive enough to actually find them. It's pretty amazing to think that we managed to prove the great Einstein wrong on that one specific point.
So what does this all really mean? Well, it means we have a brand new sense to explore the universe with. It's not just about seeing anymore, now we can hear. We're stepping into an age of precision astronomy, getting the clearest views ever of things like black holes and finally unlocking the secrets of the universe's most extreme events.
This one single breakthrough just blows the doors wide open. It leaves us with this incredible, tantalizing question. Now that we can finally, truly listen to the cosmos, to the symphony of space-time itself, what other secrets has the universe been waiting to tell us?